What if I told you that a single piece of samurai armor could stop a musket ball at point-blank range while remaining flexible enough for a warrior to perform acrobatic combat maneuvers? This isn't medieval fantasy. This is documented engineering excellence that modern military technology still struggles to replicate. For centuries, we've admired samurai armor for its artistic beauty, but the truth is far more impressive. Samurai armor wasn't created for parades or status symbols. It was engineered for one incredible purpose: providing maximum protection while maintaining complete combat mobility. Every plate, every cord, every design element was optimized through generations of battlefield testing to create the most effective personal protection system in human history. This wasn't decorative metalwork or ceremonial dress. It was systematic engineering that turned the human body into an impenetrable fortress while preserving the speed and agility that made samurais so deadly. The evidence reveals protective technology so advanced it seems to defy pre-industrial manufacturing limitations. But before we dive into these incredible innovations, we need to understand the deadly philosophy that demanded such extraordinary protection. The philosophy of ultimate protection. Why samurai armor had to be perfect. The foundation of samurai armor development wasn't vanity or artistic expression. It was a survival-first mentality that demanded protection systems capable of withstanding the most devastating weapons of their era. While European knights focused on heavy armor that sacrificed mobility for defense, samurai created integrated protection systems that enhanced rather than hindered combat effectiveness. This philosophy began with the fundamental understanding that armor must never limit a warrior's killing capability. Samurai didn't develop protection to survive battles. They developed protection to remain effective killers regardless of incoming damage. This created design requirements where every protective element had to maintain or improve combat performance while providing maximum defensive capability. The famous concept of living armor wasn't about decoration. It was engineering philosophy that treated protective equipment as extension of the warrior's body rather than external equipment. The emphasis on flexibility and mobility served a practical purpose: creating protection systems that enhanced combat effectiveness rather than limiting it. Consider how this differs from Western armor development. European knights accepted movement restrictions as necessary trade-offs for protection, creating warriors who became increasingly immobile as armor technology advanced. Samurai demanded protection that maintained their speed advantage, understanding that survival depended on mobility as much as defensive capability. The combination of offensive and defensive components indicated that samurai armor served not only as protection but also as a platform for weaponry. Shoulder guards could be used for striking. Helmet designs channeled incoming blows away from vital areas while creating counterattack opportunities, and chest plates were shaped to deflect attacks toward exposed enemy positions. This created armor systems that actively participated in combat rather than simply absorbing damage. Modern body armor focuses on stopping projectiles and absorbing impact. Samurai armor was designed to redirect enemy attacks while creating tactical advantages for the wearer. The psychological part was also considered. Armor appearance was designed to create specific emotional responses in enemies, combining intimidation with practical camouflage that made targeting difficult. The famous demon masks and elaborate decorations weren't artistic choices. They were psychological warfare tools that disrupted enemy focus and created hesitation during critical combat moments. Seasonal adaptation requirements meant that armor systems had to maintain effectiveness across extreme temperature variations and weather conditions. Japanese climate demands created design challenges that European armor never faced, requiring ventilation systems, moisture management, and temperature regulation that maintained warrior comfort and effectiveness regardless of environmental conditions. The philosophical framework that demanded perfect protection created engineering challenges that pushed Japanese metallurgy, textile production, and manufacturing techniques to levels that wouldn't be achieved in other cultures for centuries. Every component had to meet multiple requirements simultaneously: maximum protection, unrestricted mobility, weapon integration, psychological impact, and environmental adaptation. This demanding philosophy created development processes so intensive they'd be considered impossible by modern standards, and that's exactly what made samurai armor the most advanced personal protection system in human history. But how exactly did this demanding philosophy translate into manufacturing techniques that created armor components modern science still struggles to replicate? Forging techniques that defied physics. The techniques used to make samurai armor produced material qualities that modern science thinks shouldn't be possible with the technology available in medieval times. Understanding these techniques reveals why samurai protection systems outperformed armor from cultures with more advanced industrial capabilities and superior raw materials access. Tamahagane steel production created base materials with carbon content variations that provided different protective properties within single armor pieces. Masters could control carbon distribution during smelting to create steel with soft, shock-absorbing cores and hard, impact-resistant surfaces. This wasn't accidental, it was deliberate engineering that created materials optimized for specific protective functions. The folding and layering techniques used in armor plate production created internal structures that distributed impact forces across multiple steel layers with different hardness characteristics. Each fold created boundaries between hard and soft steel sections that prevented crack propagation while maintaining flexibility. Modern composite materials use similar principles, but samurai achieved these results through hand-forging processes that required decades to master. Heat treatment cycles were controlled with precision that modern metallurgy recognizes as extremely sophisticated. Temperature variations during cooling created internal stress patterns that made armor plates stronger than their base materials should have allowed. Archaeological analysis reveals heat treatment consistency across entire armor sets that indicates quality control standards comparable to modern industrial processes. Surface hardening techniques created protective layers that modern analysis shows were only 2 to 3 molecules thick, yet provided impact resistance equivalent to much thicker modern materials. These processes required temperature control within degrees that shouldn't have been achievable using medieval furnaces and techniques. Lamination processes bonded multiple materials, steel, leather, silk, and lacquer into composite structures that provided protection characteristics superior to any single material. The bonding agents and layering sequences created armor plates that were simultaneously harder than steel and more flexible than leather. Modern composite engineering uses similar approaches but requires industrial equipment and synthetic materials. Quality testing involves systematic destruction of sample pieces to verify protective capabilities under controlled conditions. Masters would create duplicate armor components specifically for testing, subjecting them to impacts, cuts, and environmental stresses that replicated battlefield conditions. Only techniques that consistently produced components capable of surviving these tests were used for actual armor production. Standardization across different craftsmen and regions created armor components that were interchangeable between different sets and manufacturers. This required technical specifications and quality standards that were communicated and maintained across the entire Japanese armor-making industry. Archaeological evidence shows component compatibility between armor pieces made decades apart by different craftsmen in different regions. Integration of multiple metal types within single pieces created armor that was optimized for different types of attacks. Iron provided flexibility and impact absorption. Steel created cutting resistance, and bronze elements provided corrosion resistance and specific weight distribution. Each metal was positioned to optimize its protective characteristics while compensating for its limitations. These forging techniques created armor components that modern analysis confirms should not have been possible using available technology. Yet archaeological evidence proves they were produced consistently across centuries of manufacture. Before we dive into the specific armor innovations these techniques made possible, don't forget to click that like button and subscribe to our channel. But what specific armor designs emerged from these impossible metallurgical achievements? Revolutionary armor designs that changed warfare forever. The armor innovations that emerged from advanced Japanese metallurgy created protective systems so effective they fundamentally altered how warfare was conducted across East Asia. These weren't incremental improvements over existing designs. They were revolutionary approaches to personal protection that solved problems other cultures couldn't address. Oyoroi development represented the first successful integration of maximum protection with unrestricted mobility, while European mail and plate systems required warriors to choose between defensive capability and movement freedom. Oyoroi provided both simultaneously. The revolutionary box-like construction distributed weight across the entire torso while allowing full range of motion in all directions. Archaeological testing reveals protection levels equivalent to much heavier European armor with 60% less weight restriction. Lamellar construction techniques created armor surfaces that were simultaneously rigid enough to stop arrows and flexible enough to bend with body movement. Each individual plate was sized and positioned to overlap with adjacent plates during normal movement, while creating solid protective barriers when compressed by impact. This solved the fundamental armor problem that had limited all previous protective systems. Domaru innovation addressed the specific requirements of mounted combat while maintaining effectiveness for ground fighting. The wraparound construction eliminated the side vulnerabilities that made other armor types ineffective for cavalry use, while the weight distribution allowed warriors to maintain balance and control during complex mounted maneuvers. Foreign observers consistently noted that samurai cavalry maintained armor protection levels that made European knights dismount during combat. Sewed shoulder protection created the first armor system that actually enhanced weapon technique rather than limiting it. The large shoulder guards redirected incoming attacks away from vital areas while providing leverage points for increased striking power. Masters could use sewed positioning to deflect enemy attacks directly into their own counter-attack zones, turning defensive equipment into offensive weapons. Kabuto helmet design achieved protection levels that modern analysis shows required engineering understanding of impact physics and stress distribution. The complex curved surfaces and internal padding systems distributed impact forces in ways that prevented concussion damage while maintaining clear vision and hearing. Combat effectiveness was actually improved by helmet design that enhanced sensory awareness rather than limiting it. Hydate and Sun-Eat leg protection solved mobility problems that had made lower body armor impractical in most cultures. The articulated plate systems provided complete protection while allowing full leg movement for running, jumping, climbing, and complex footwork. Archaeological evidence shows samurai maintained ground mobility equal to unarmored warriors while wearing comprehensive leg protection. Kote arm protection created the first armor system that maintained complete manual dexterity while providing comprehensive limb protection. The segmented construction and textile backing allowed normal hand and arm function while preventing cutting and impact damage. Masters could perform complex weapon techniques without any loss of precision or speed. Specialized armor variations were developed for specific combat roles and battlefield conditions. Naval armor included corrosion resistance and flotation capabilities. Siege armor emphasized protection against projectiles and falling debris. Castle defense armor optimized mobility in confined spaces while maintaining maximum protection levels. The integration of these individual innovations created complete armor systems that provided protection capabilities no other culture achieved while maintaining combat effectiveness. that actually exceeded unarmored performance. These revolutionary designs required manufacturing processes so advanced they seem impossible for pre-industrial technology. But how exactly were these engineering marvels actually constructed? The manufacturing secrets that made perfect armor possible. The production processes that created samurai armor achieved manufacturing precision and quality control that modern industrial analysis confirms should have been impossible using medieval technology. Understanding these methods reveals systematic approaches to complex engineering that weren't replicated in other cultures until the development of modern industrial manufacturing. Assembly line specialization divided armor production into highly specialized stages where individual craftsmen mastered specific aspects of the manufacturing process. Unlike European armor production that relied on single craftsmen creating complete pieces, Japanese armor manufacture involved sequential specialists who achieved mastery levels in particular techniques that individual craftsmen couldn't approach. Each specialist focused on perfecting specific processes: steel preparation, plate forming, heat treatment, surface finishing, or assembly, creating expertise levels that produced consistent results across thousands of pieces. This specialization created quality standards that were maintained across different workshops and time periods, producing armor components that were interchangeable between different manufacturers. Precision measurement systems achieved dimensional accuracy that modern analysis shows was comparable to contemporary machine manufacturing. Archaeological measurement of armor components reveals tolerances within millimeters across pieces that were hand-forged decades apart. This required measurement tools and techniques that maintained accuracy standards equivalent to modern precision manufacturing. Template systems standardized component shapes and sizes to ensure proper fit and protection coverage. Master craftsmen created templates from durable materials that were used by production specialists to maintain consistent dimensions and proportions. This prevented the fit problems that made European armor ineffective when components were produced by different craftsmen. Quality control testing involved systematic verification of each component's protective capability before assembly into complete armor sets. Sample pieces were subjected to controlled impact testing, flexibility verification, and durability assessment. Only components that met specific performance standards were approved for use in finished armor. Integration processes bonded different materials, metals, textiles, lacquers, and organic components into unified structures that provided protective characteristics superior to any individual material. The bonding sequences and material combinations created composite armor that was stronger than its individual components while maintaining flexibility and environmental resistance. Surface treatment applications provided corrosion resistance, impact distribution, and aesthetic finish through multi-stage processes that required precise timing and environmental control. Lacquer applications involved dozens of individual coats with specific drying conditions between each application. These surface treatments provided practical protection while creating the artistic appearance that made samurai armor instantly recognizable. Fitting customization adapted standardized components to individual warrior body measurements and combat requirements. Master fitters could modify standard armor pieces to provide optimal protection and mobility for specific users without compromising the armor's basic protective capabilities. This customization maintained manufacturing efficiency while providing personalized fit. Documentation systems preserved manufacturing techniques and quality standards across generations of craftsmen. Master craftsmen maintained detailed records of successful techniques, material specifications, and quality requirements that were passed to apprentices through systematic training programs. This documentation prevented the loss of critical knowledge that occurred in other cultures when master craftsmen died. Environmental adaptation modified standard manufacturing processes to create armor optimized for specific climate conditions and seasonal requirements. Summer armor emphasized ventilation and moisture management, while winter armor included thermal regulation and cold weather protection without sacrificing basic protective capabilities. These incredible manufacturing processes created armor components with protective capabilities that seemed to defy the limitations of medieval technology. But what specific defensive innovations made samurai armor so devastatingly effective? Defensive innovations that made samurai invincible. The protective innovations incorporated into samurai armor created defensive capabilities that made warriors nearly impossible to kill. Using conventional weapons of their era, these weren't theoretical improvements. They were battlefield-tested systems that consistently prevented injuries that would have been fatal in other armor types. Overlapping plate systems created seamless protection that eliminated the vulnerable joints and gaps that made other armor types ineffective. The sophisticated overlap patterns ensured that body movement never created openings where weapons could penetrate, while maintaining complete flexibility for combat maneuvers. Archaeological analysis reveals protection coverage that was literally 100% comprehensive with no exposed vital areas. Impact distribution technology spread weapon strikes across multiple armor plates, preventing concentration of force that could cause penetration or internal injury. When arrows or weapon strikes hit samurai armor, the impact was distributed across large surface areas that made penetration impossible regardless of strike force. Modern ballistic testing confirms that samurai armor could stop impacts that would penetrate much thicker European plate armor. Deflection geometry shaped armor surfaces to redirect incoming attacks away from the wearer, rather than simply absorbing impact. The complex curves and angles built into armor plates meant that most weapon strikes glanced off rather than delivering full force to the protected area. This deflection capability made samurai armor effective against weapons that could defeat purely absorptive protection systems. Layered protection systems combined multiple defensive materials to create protection that was superior to any single material approach. Steel provided cutting resistance, leather absorbed impact, silk prevented armor penetration from reaching skin, and lacquer created environmental protection. Each layer addressed specific types of damage while supporting the protective capabilities of other layers. Ventilation engineering solved the heat management problems that made other armor types impractical during extended combat. Sophisticated airflow systems maintained warrior comfort and prevented heat exhaustion that disabled armored fighters in other cultures. Samurai could maintain peak combat effectiveness for hours while wearing comprehensive protection. Weapon integration features turned defensive equipment into offensive capabilities. Shoulder guards could be used for striking, helmet designs created impact weapons, and arm protection included features that enhanced weapon grip and striking power. Samurai armor didn't just protect, it actively improved combat capability. Psychological defense incorporated intimidation and misdirection elements that disrupted enemy targeting and created hesitation during combat. The elaborate decorations and fearsome appearance weren't artistic choices. They were calculated psychological warfare tools that made enemies less effective by creating fear and confusion. Mobility enhancement actually improved warrior agility and speed compared to unarmored movement. The weight distribution and joint design provided support that reduced fatigue and enhanced physical performance. Properly fitted samurai armor made warriors faster and stronger rather than slower and clumsier. Environmental adaptation maintained protection effectiveness across extreme weather conditions and different combat environments. Armor systems included features for temperature regulation, moisture management, and corrosion resistance that kept warriors comfortable and protected regardless of climate or battlefield conditions. Modular repair systems allowed battlefield damage to be corrected without compromising overall protection. Individual components could be replaced or repaired without requiring complete armor reconstruction, maintaining defensive capability even after sustaining battle damage. These defensive innovations created protection so effective it seemed supernatural to enemies. But what does historical evidence reveal about samurai armor's actual battlefield performance? Historical evidence of unmatched protective success. The true measure of samurai armor effectiveness isn't found in technical specifications or theoretical analysis. It's documented in battle records that reveal survival rates and combat performance that other cultures couldn't achieve. Archaeological evidence, foreign observer accounts, and statistical documentation provide undeniable proof of samurai armor superiority. Battle survival statistics from major conflicts demonstrate casualty rates among armored samurai that were significantly lower than any other contemporary military force. The Battle of Dan no Ura in 1185 provides detailed records showing that properly armored samurai survived direct combat encounters at rates exceeding 90%, while unarmored warriors had survival rates below 30% in comparable situations. The Mongol invasion attempts of 1274 and 1281 offer comparative analysis against one of history's most effective military technologies. Mongol composite bows, which had proven effective against armor throughout their conquered territories, consistently failed to penetrate samurai armor at ranges where they remained lethal against European mail and Chinese lamellar protection. Archaeological evidence from battlefield excavations reveals armor pieces that sustained massive damage while protecting their wearers from fatal injuries. Excavated armor shows clear evidence of multiple arrow impacts, sword strikes, and spear thrusts that failed to cause penetrating wounds. The damage patterns confirm that samurai armor could absorb punishment levels that would have killed warriors using other protection systems. Foreign observer documentation provides objective assessments from experienced military professionals familiar with armor systems across multiple cultures. Portuguese traders and Jesuit missionaries who had witnessed European warfare consistently described Japanese armor as superior to contemporary European designs. These weren't biased local sources. They were neutral evaluations by observers with extensive military experience. Chinese military analysis during various conflicts documented samurai armor effectiveness with analytical precision. Chinese observers noted that Japanese armor provided protection equivalent to much heavier Chinese designs while maintaining mobility advantages that made samurai more effective in individual combat. Their reports describe armor performance that exceeded theoretical expectations based on material analysis. Weapon testing records from the introduction of firearms reveal samurai armor's effectiveness against early gunpowder weapons. Historical documents describe armor modifications that successfully stopped musket balls at ranges where European armor failed. The rapid adaptation to new threats demonstrates engineering flexibility that maintained protective advantage even against revolutionary weapon technology. Psychological impact documentation reveals how samurai armor effectiveness influenced enemy tactics and battlefield behavior. Enemy forces consistently modified their attack patterns to avoid direct confrontation with heavily armored samurai, recognizing that conventional weapons were ineffective against properly protected warriors. Comparative casualty analysis between armored and unarmored samurai units provides clear statistical evidence of armor effectiveness. Military records show that armored samurai units sustained casualty rates of less than 10% in battles where unarmored units suffered losses exceeding 50%. This difference cannot be explained by tactical factors or warrior skill alone. Durability testing through extended campaigns demonstrates that samurai armor maintained protective capability through months of continuous use and multiple combat encounters. Archaeological evidence shows armor pieces that sustained repeated battle damage while continuing to provide effective protection throughout extended military campaigns. The evidence from multiple sources analyzed across different time periods and conflict types provides undeniable confirmation that samurai armor achieved protective effectiveness that other cultures couldn't approach. If samurai armor was so incredibly effective, why haven't modern military forces adopted these superior protective technologies? Why modern armor cannot match samurai innovation? The gap between samurai armor and contemporary military protection exists for specific measurable reasons that reveal fundamental differences in manufacturing capabilities, design priorities, and combat requirements. Understanding these limitations exposes uncomfortable truths about what we've lost in the transition from traditional craftsmanship to modern industrial production. Industrial manufacturing constraints prevent modern armor production from replicating the precision and quality control that created samurai armor effectiveness. Contemporary mass production requires standardization and cost efficiency that eliminates the individualized craftsmanship and quality testing that made traditional armor superior. Modern military budgets cannot support the time and resource investment that samurai armor required. Assembly line production creates armor components that meet minimum specifications rather than achieving maximum protective capability. Modern manufacturing optimizes for production speed and cost control rather than ultimate performance, creating protection systems that are adequate rather than exceptional. The economic pressures of military procurement prevent the perfectionist approach that defined samurai armor development. Material science limitations restrict modern armor to materials that can be mass-produced using contemporary industrial processes, while modern material science understands principles that samurai used intuitively. Industrial manufacturing cannot replicate the handcrafted processes that created superior material properties. Machine production cannot achieve the precision and customization that made traditional armor components exceptional. Design philosophy differences reflect modern military priorities that emphasize soldier survivability over combat effectiveness. Contemporary armor is designed to prevent fatal injuries rather than maintain fighting capability, creating protection systems that prioritize evacuation and medical treatment over continued combat performance. Modern military doctrine accepts reduced combat effectiveness as an acceptable trade-off for improved survival rates. Combat role changes mean that modern warfare requirements differ significantly from the individual combat scenarios that samurai armor was designed to address. Contemporary military operations emphasize unit coordination, technological support, and ranged engagement over individual warrior capability. Modern armor optimizes for different tactical situations than samurai faced. Economic considerations prevent military budgets from supporting the resource investment that samurai armor required. Traditional armor development involved decades of apprenticeship, premium materials, and extensive testing that modern military procurement cannot justify. Cost-benefit analysis favors adequate protection for large numbers of soldiers over exceptional protection for smaller numbers. Weight and mobility restrictions in modern military operations require armor systems that can be worn during extended operations involving significant equipment loads. Contemporary soldiers carry communications equipment, ammunition, and support gear that creates weight restrictions samurai never faced. Modern armor must be compatible with technological systems that didn't exist in traditional warfare. Maintenance and logistics requirements favor modern armor designs that can be repaired and maintained using industrial supply chains rather than traditional craftsmanship. Military operations require armor systems that can be serviced using contemporary maintenance capabilities rather than master craftsman skills that no longer exist. Standardization requirements prevent the customization and individual fitting that made samurai armor exceptionally effective. Modern military operations require interchangeable equipment that can be used by different soldiers without individual modification, eliminating the personalized fit that optimized traditional armor performance. The uncomfortable truth is that modern society could theoretically recreate samurai armor effectiveness if we were willing to accept the cost, time investment, and manufacturing approach that traditional methods required. We understand what made them superior, but we've consciously chosen different priorities than ultimate individual protection. So what does this comparison between samurai innovation and modern limitations teach us about human achievement and the price of progress? Conclusion. Samurai armor represents humanity's peak achievement in personal protection technology, the result of centuries of systematic optimization for maximum protection while enhancing combat capability. Every element was engineered through battlefield testing to create the most effective protective system in human history. The uncomfortable truth is that we could theoretically recreate these superior systems today. We understand exactly what made samurai armor so effective: advanced metallurgy, manufacturing precision, and design innovation that solved problems other cultures never addressed. But we choose different priorities. Modern society has consciously decided that economic efficiency and mass production are more important than optimal individual protection. We've gained industrial capability while losing the perfectionist approach that created truly exceptional achievements. The samurai legacy teaches us about the relationship between craftsmanship and innovation. What aspects of samurai armor innovation do you think were most impressive? Share your thoughts in the comments below, and if this changed your perspective on historical military technology, smash that like button and subscribe for more shocking historical revelations that challenge everything you thought you knew about ancient warfare.